we summarize, again, think of these statistics as summary calculations that are representing the visual. The mean is hopefully, if it's a good measure of central tendency, represents the middle of the data, the more typical value, a measure of location, where most people fall in and around. That's what the mean is supposed to be, or an average is supposed to be. The mean may be that, it may not be that, depending on the shape of the data. And then we need a measure of spread, which is we begin with the standard deviation around the mean, as a measure of how variable the data is around the mean. So again, these are mathematical calculations that represent, summarize the variation for us. And so the first one is this. And again, you're assuming you're okay, most of you are okay with formulas. Again, it's an overkill of a formula in a way to begin with, but formulas are a necessary way of summing up what we want to calculate. You can't write out in words all the time. But basically, sample mean is our first measure of central tendency, the middle of the data, where you're simply adding up all the values and dividing by the sample size. And that's what the summation from 1 to n means. I equal 1 for the first value to the nth value, say 200 values. Add them up, add up all the values from 1 to 200 if you have 200, whatever. Divide by 200 the sample size. That's the sample size, and you get your sample mean. So it's a measure of central tendency. So if you can imagine picking up this histogram, balancing it on your finger, that's where the mean would be. It's a balancing point in the middle of the histogram. Summarizes the middle of the data. And most people are in around that value. And so yeah, that's all it was. That's the total number in centimeters. Total centimeters divided by the sample size for this data, and 174 centimeters right there in the middle. Okay, so all right. So when deciding on whether weight loss program to use, what else would you like to know about this data besides the mean? If you have 2 weight loss programs and you calculate a mean for both, and they both turn out to be 20 pounds, you may say, oh, they're equally effective. But on average they are, and we do compare averages. You want to see how consistent it is. We need a measure of variability around that measure of central tendency. So the other thing to understand is that the mean is a measure of central tendency, a typical value in the middle of our data, and then we'll reason around the mean. We'll reason with the variation around the mean, or the variability in the data around the mean. So it's from the center outwards is the way to think of it. And we need to understand variability. The more variability too, the more uncertainty we'll have about how effective a drug is. So variability around the average or the mean in this is something we have to think about, because here, a hypothetical weight loss program, say in pounds, you could have a mean in both cases, but you could have one person losing 55 pounds and another person gaining 15 pounds and negative 15. So there's more uncertainty in how effective that program is for individuals compared to down here. So more variability, more uncertainty. So wider variability, more uncertainty. So we need a measure of that. We need to be able to measure the variability around the mean. And so that's the standard deviation. Our measure of spread or variability around the mean is called the standard deviation, sample standard deviation. As a stepping stone for getting that value, we have to calculate what's called the standard sample variance. If anyone wants to throw in a chat, who knows or surmises, why is it like a standard deviation, or we want to get a measure of the average deviation. A deviation is just the distance between a value and the mean. That's a deviation. We want a measure of the average deviation of values around the mean. And so what you're seeing here is we're summing up the deviations, the square deviations, and dividing by the sample size -1. Let's not worry about the -1 for right now. That's a mathematical correction. But we're summing up the square deviations instead of just summing up the deviations and dividing by the sample size -1. Why do anyone want to say why we think we have the square deviations before we can sum them up? Yeah, so great. Yeah, because deviations can be negative. And so squaring them makes them all positive, gets rid of the negatives, avoids negation. So yeah, thank you and for throwing all. And it's nice to see different ways of explaining it too. Like you know, let's work together to just make this as best experience as possible. And can you save these chats, because I can always upload them if can't, so that you can see them afterwards. But you can let me know, can you save them? Because thank you, Dylan, for showing me how to do it yesterday. But yes, they'll all add up yeah, if we don't square them. So the convention with squaring has better properties than absolutes. Absolutes may have worked too. Yes, you can say them ourselves. That's good to know. Great, thank you, Juliet. Yeah, so squaring has better properties. I was in linear regression, where we end the course again. There is an arc to this course where this will come up again, the linear regression and deviations and outliers and large deviations and all that sort of thing. Better properties for coming up with the line we fit to data, height, weight data, and fit a line, linear regression. Better properties of squaring. So that's what we have to do. And so anyway, for anyone this is not a whole lot of math, just summing up the square deviations divided by the sample size. Easy to do in Excel. The best way to do it is in Excel. Take the values in a column, get the mean, and then just take that value away from every value in the column, then have another column for squaring, and then sum them up. If you're going to be doing this as part of any homework, I think I might ask you to do it by hand at least once. You can use Excel to do it. Lay out the steps. So again, there are the steps. You can read them. Again, if you're doing it by hand, but you may have to do it once by hand in your homework or twice in a small data set, but that will be it. Okay, so again, here's showing it. This is for the men's heights data. This is in the appendix of my text because we stay away from the math altogether. But it might be good, again, I think in your homework, do it once just to get a sense of what you're doing. You know, because deviations are important in statistics and thinking about deviations from means. So how far does this value deviate? That was the smallest height, the shortest man. That was the tallest man in centimeters. And the mean was 174. And we're just getting, for every value, squaring the vitamin. And that gives us the variance, what we call sample variance. Variance is very important, especially if you're going into the medical field, analysis of variance. I don't cover it here much. We'll talk about it in linear regression. We'll definitely talk about the analysis of variance table. You'll get some understanding of it. But variance is a statistic that's used. It's the squared term, but it can be analyzed as a relative term, one variance relative to another in analysis of variance, ANOVA. Right now, it's just a stepping stone towards what we want, the sample standard deviation, which is the square root of the variance, and it's 7.7. So what does it mean, briefly? If you were to select a man at random, we would expect their height to be about 7.7 centimeters from the mean, but it could be further. I mean, it would not be exactly, but on average, we'd expect it to be that far away. The larger the value, the more variability in our data, basically. And so around the mean. So it's a mean out, it's around the mean. Okay, again, this is one of my texts. Again, I don't have much time for conversation, but what do you notice, though? Anything you notice about, this is college football and concussions, using hippocampal volume as a measure of cognitive ability and in your brain. And so is there anything straight off the bat? Again, the key way to step into analysis is start calculating, grading histograms, and we do box plots as well. We'll look at a box plot for this. But then summary statistics, means and standard deviations. Knowing the mean is a typical value, and standard deviation is a measure of variability around that value. Can anyone just say, and you can put it, you can say it out loud if you want, or in the chat. You know, what do you notice about the values of the means and standard deviations for the controls compared to players with and without concussion? Yes, both values are much larger for controls. And another comment about the values of standard deviation. Yeah, the standard deviations are going down. So yes, the falling and the variability is narrowing. So it's kind of like you sense a contraction going on. You know what I'm saying? It's kind of like the means are hippocampal volume is falling and they're narrowing in around those smaller values. So what I'm trying to point out here, right off the bat, like you can start to think about what the data is telling you, and we'll analyze it again later on statistically. I'll put in the results of the analysis comparing these groups, comparing the means later on. And again, it's observational, so you can't make causal conclusions. But again, if the study is a good read, it's a short read, and a nice, well-written study, and it's a good one to maybe start with, reading studies, just something that might be of interest to you, and just to see that, like a good study also will describe the limitations and will discuss confounding factors. So it's a good study for that. If you read that one, it's a good start to read that one, because it's maybe of interest, and then also a good researcher understands that they're just in a process towards truth, and that they really say lessons learned is what they got out of this study, and that. So it's worth reading.